Okay, so in this next segment of the video series, we're going to pick up where we left off and inject a sample of Durban poison cannabis that we've just made into the GC and see what the answer came out to be. So we just finished making a calibration chromatogram, which is something that unfortunately you have to do every day. There's no law that says you have to do that, but it's good scientific practice to verify that you are in calibration before you start analyzing unknown samples. So the way you do this, in the morning you come in, you just make sure you're filled with water here. You make sure that you've emptied the water trap. If the water trap is more than half full, then empty the water trap by turning this little valve, and all the water will spurt out this tube. We'll do that later so you can see it. I don't want to do it right now because you have to wait a few minutes after you do that for everything to kind of build back up. So we want to inject this sample. We're looking at the water, everything looks good. Here's our calibration chromatogram. We've already calibrated. I'm going to copy this calibration chromatogram to another channel in the software where it just sits until we do something with it, but we can kind of use it as an overlay so that we can see that the peaks that we're going to measure coming out of the Durban poison actually do line up in time with the calibration chromatogram. So with the sample bottle, I usually remove the top. You don't have to. You could poke through it with your syringe, but you can reuse these sample bottles forever, really. Just dump it out, put in a little clean acetone, swish it around, and then it's good as new for the next sample. So I'm going to take my syringe here, and I'm going to pump, pump, pump 1,000 times, just like ever. You want to try to avoid sucking in little bits of solid cannabis if there is any floating around. Try to just get the water, and don't shake it up at the end. Let everything kind of settle down to the bottom, so it's easy not to get any solids into the syringe. So you pull it up to the 1 mark, just like I did before, and then back to the 4 mark so that I can actually see the 1.5 microliters of liquid in the syringe. Take a look around, no rush. Poise my syringe up against the rubber septum, but being careful not to go through the septum. Just poising it there so I don't have to hunt and peck when I finally decide I'm ready to inject. And then when I am, I hit the start button first, immediately ram it in up to the hilt, depress the plunger, and then pull it out. So now we're going to see what the sample looks like. And I'm also going to click on channel details, and I'm going to say overlay the data that's in channel 2, and that way we can see the calibration chromatogram ghosted in the background, while the chromatogram from the sample that we're running right now appears in black on top of the red overlay. So it's important to understand how we arrive at the answer in the units of percent, right? Because we did get an answer when we did the calibration. We got an answer that was 13.32%. So I hate to have to do the math, but you have to understand how we arrive at the answer in percent of the starting material, which is the answer that you want to know. How much percent of THC is in that Durban Dragon cannabis. So we have to review what we did. So we started out with the ampule from Restec, the calibration standard, and it says right on the bottle what the concentration of THC or CBD is. In this case it says 1,000 micrograms per milliliter. So 1,000 micrograms per 1 milliliter is the same as 1 million nanograms per 1 milliliter. And if I divide a million on the top by 1,000 and a milliliter on the bottom by 1,000, it's the same as 1,000 nanograms per 1 microliter. So the reason we want to talk in these units, nanograms per microliter, is that is the weight of the cannabis in the sample that we injected. We're injecting 1 microliter. What we really want to know is how much weight of CBD or THC is in the 1 microliter that I just squirted into the GC. So what we did next in an earlier segment of the video is we had 3 bottles that we made from the Restec. I call it a Restec standard, but it really could be from any of the other fine suppliers of calibration standards. But when I transferred the ampule into the bottle and I made the label would have said 1,000 nanograms per 1 microliter for each of these. They're all at 1,000 nanograms per microliter. But then we took 100 microliters of each of those, and we put it into another little auto sampler vial, right? That's our calibration standard. So we diluted the three, the CBD, the THC, and the CBN, we diluted them into 300 microliters of liquid, but the concentration was then 333 nanograms per microliter because they diluted themselves equally three ways. So even though they each started at 1,000, they ended up at 300 microliters. So the calibration standard label that I wrote says 333 nanograms per microliter because that's what I measured in there. So then we made a sample, right? And we started with a much bigger 40 milliliter bottle here. A 40 milliliter bottle holds this 40 milliliters of liquid, which is the same as 40,000 microliters of dirty solvent. And let's imagine that we put some pure THC in the bottle. Really what we did was we put 105 milligrams of Durban poison in there, but let's just imagine, for the sake of making the math easy, that we put 100 milligrams of 100% THC in there. So we put that and we let the THC dissolve in there, and the question then would be how much THC would be in each microliter of liquid, because that's what I did. I took a microliter of liquid out of that, and I want to know, if I do that and squirt it into the GC, how much THC am I squirting in there? So the way to figure that out is to convert the 100 milligrams to 100,000 micrograms. Same thing, 100 milligrams, 100,000 micrograms, which is the same as 100 million nanograms, right? So if I put 100 million nanograms of pure THC in the bottle, how much would be in each microliter? Well, to find out, you take the 100 million nanograms divided by the 40,000 microliters, and that turns out to work out to 2,500 nanograms per microliter. And that's if it's 100% THC. So imagine if it was 10% THC. It's easy to do the math in your head. 10% THC would correlate to 250 nanograms per microliter. That would be the equivalent of starting out with 100 milligrams of 10% THC. But we injected what's on our calibration standard bottle, which says 333 nanograms per microliter, and that's somewhere between 2,500 and 250, somewhere in here. So 333 nanograms per microliter works out to 13.32%. That's how we arrive at the answer in percent, is we calibrate in nanograms per microliter, but we convert the answer to percent in this screen called the results screen. Right? There's a place here in the results screen to put in a number for the standard weight and also for the sample weight. So in the case of the calibration standard, it's always 100, because this whole math is based on 100 milligrams of stuff into there. Now, if you put more or less, it doesn't matter. You just put whatever the weight that you weighed into the bottle in this other field called sample weight. So I put in 105 for the weight of the Durban poison that I put in there, and then we get our corrected answer because we put in the corrected weight. So here now we've got the chromatogram from the Durban poison sample. So we've got our internal standard peak came out just exactly where it did when we injected the calibration standard. And you can see the calibration standard is ghosted in red so that we can see that these things all really do line up in time. And then over here with the CBD, there's a little tiny bit of CBD, but not an awful lot. There's a peak here. We don't really know for sure what it is, but I'm 99% sure it's Delta 8 THC. And then we've got this very large peak that came out right when the Delta 9 calibration standard peak came out. And then we've got this peak here, which comes out just after Delta 9 THC, and we don't know what that is for sure either, but it really is CBG. That's where CBG comes out on this pattern. And then we've got the CBN. So even though it's labeling it as Delta 9 THC, it's because the window is so wide that it's picking up the tippy tops of both peaks. So I'll just make the the window a little narrower so it only identifies the THC peak as THC, and it doesn't really know what that peak is at this point in time. It's easy to calibrate for that peak, but we didn't do it because we only used the 3 cannabinoid standards initially. We can go back later and calibrate for CBG if you aren't sick of watching these videos by then. Okay, so let's go see what the answer is. So we'll go to the results screen, and we'll see that based on the sizes of everything, it's calculating out the Durban poison to be 15.307%. The CBD is calculating out as to be 0.19%, and the CBN is 2.61%. You can see just looking at the picture visually that seems like that's correct. But the devil is in the details, and you do sometimes have to zoom in and make sure that this blue line, see there's a blue line that kind of tracks along the black data line. We call the blue line the baseline, and we call the black line the data line. So the job of the blue line is to figure out where the bottom of the peak is. So there are times when it's just not sure where the bottom of the peak is. It could be one way or another, like in this little group of 3 peaks. You can see how it decided to draw the blue line to the valley between the peaks, but really it could have just as well gone the other direction and drawn a flat line across the bottom so that the areas of the peaks were bigger now because of the way that we drew the blue line. So it can make some difference. So let's see how much difference it would make for the THC peak. So I'm going to unzoom here just a bit so you can remember what it looked like here. This big one is the THC, and this next one is the CBG. So I'm going to zoom in a little bit so we can see, and we can see the blue line kind of went on an angle up to here and then down. So if I wanted to correct that, I have this toolbar here called the manual integration toolbar, which I can turn on or off, and it gives me various tools that I can use to override the decision of the fuzzy logic algorithm that decides where the bottom of the peak is. So here I'm going to take my little rubber band tool and I'm going to draw the rubber band like that. Okay, so before I do that, let's display the results, right? So the results are showing 15.3% for THC. So when I do the rubber band and draw the baseline like that, now it's 15.37. So it made a tiny difference. It's somewhat subjective. Different analysts will make different decisions about how, but it's one of the bigger sources of error in the analysis, and the operator really has to control that by zooming in and looking and saying, okay, it did do it the way that I would do it, and if I don't like it, I can fix it. I have all these tools available. We won't go into all the tools that we have right now, but there are tools that help you manipulate this. It's an important thing that the operator has to accomplish with the GC, because the GC is not really a push-button device. It's more like a piano. You have to learn how to play it, and it does get better with more practice. So these are some of the things that you have to know. Anyway, let's print the results out. So I've got the printer on, and I'm going to go to the printer icon, and I'm going to make sure that the settings are the way I like them, and then I'm going to hit print, and then out comes the chromatogram. Now if I don't want to waste paper, I can print to a PDF. So you would go to print, and you would go up here at the top, and you'd go to your PDF writer, or you'd maybe you prefer to have something like Excel, right? So I'll open Office. Hopefully I did. And while we're waiting for Open Office to come up, that's all. Alright, so here I am at Open Office. So I can either go to the Word part of Open Office, or the looks like that's what it's opened up for me here, so that's fine. So we just go here to the results screen and then hit copy, and then go to Open Office and hit paste. There's paste. There it is. Okay, so it takes the result.